Shave a chimpanzee, and you'll find something nobody expects. Pale skin, almost pink. Under all that dark fur, nearly every ape on Earth is light. Now look at the back of your hand. No fur, just skin, out in the open, dealing with the sun on its own. Whatever shade that skin is, it started as a survival decision. Because every human alive today comes from one dark-skinned population, and the palest skin on Earth, the kind that burns before the sunscreens even open, is newer than farming. So how did one species end up with every shade from near black to near pink? Here's the part almost nobody tells you. Evolution didn't find the answer once, it found it twice. Same problem, two different solutions, on two sides of the planet. This is that story. Start with the fur. Fur is sunscreen you can grow. It blocks sunlight before it ever touches skin. That's why an ape can be pale underneath and never pay for it. Then our ancestors gave it up. The leading explanation is heat. A furry body overheats fast on open ground. A bare body that sweats can keep moving through midday, walking, tracking, carrying, while everything else looks for shade. We traded the coat for the best cooling system in the animal kingdom. But that trade exposed something fragile. Bare skin under equatorial sun takes a beating. UV light burns it. It breaks the DNA inside skin cells, and enough broken DNA becomes cancer. And it does something sneakier. Scientists' best explanation goes like this. UV destroys folate, a B vitamin your body needs to build healthy babies. Too little folate, and pregnancies fail. So strong sun didn't just threaten skin, it threatened the next generation. The fix was already in our cells. Melanin, a pigment that sits over your DNA like a built-in sunshade and soaks up UV before it does damage. More melanin? Darker skin, better protection. You've seen this system switch on. A week of summer sun, and your skin darkens a shade. A tan is your melanin factory taking a rush order. The playbook is ancient, and you're still running it. Under African sun, that upgrade wasn't optional. Within the deep history of our lineage, genetic evidence says more than 1 million years ago, dark skin became standard equipment, not one shade among many, the only one. For most of human history, every single person on this planet was dark-skinned. Every hunter, every child, everyone. And if we'd stayed put, this video would end here. We didn't stay put. Around 60 to 70,000 years ago, people started walking out of Africa. Nobody planned it. Each generation just drifted a little further, along coasts, through valleys, up into Europe and Asia. And with every step north, the sun got weaker. Up there, sunlight hits the Earth at a flatter angle and loses most of its UV on the way through the atmosphere. In winter, meaningful UV barely arrives at all. Sounds relaxing. It's actually a trap. Put yourself there. A northern winter, 40,000 years ago. The sun shows up late, hangs low and gray, and leaves early. Your dark skin is doing everything right. It's blocking UV like a champion. And that's exactly what's starving you. Because your skin doesn't just block UV, it uses it. When UVB light hits skin, the skin makes vitamin D. Vitamin D is how your body absorbs calcium. Calcium is how your bones stay hard. No UV, no vitamin D. No vitamin D, no calcium. No calcium, and bones go soft. In kids, that's rickets, legs that bend under their own body weight. And for women, it got worse. A vitamin D-starved pelvis can grow deformed. And in a world without hospitals, a deformed pelvis could turn childbirth into a death sentence. That's evolution's cruelest kind of filter. It doesn't care how strong you are. It counts your surviving children. Dark skin, brilliant at blocking UV, was now blocking the tiny dose of UV the North actually offered. The shield had become the problem. So lighter skin should have spread fast, right? A few thousand years? Tops. Here's the thing. It didn't. Ancient DNA lets us read the genes of people who died thousands of years ago. And when scientists read Europe's early hunter-gatherers, they found something that broke the simple story. These people had lived in the cold, gray North for tens of thousands of years. Plenty of time to lighten. They were still dark. If that just broke your mental image of ancient Europe, you're in good company. It broke the scientist's image too. The famous example is a man from Britain, 10,000 years ago, Cheddar Man. His DNA points to dark skin, and at the same time, blue eyes. A combination almost nobody expects, sitting right where Britain keeps its palest weather. Hold that thought, because how anyone can know the color of a man that old is its own story, and we'll come back to it. But first, the real puzzle. The vitamin D problem was real. The rickets, the pelvis filter, all of it. So how did dark-skinned people survive the sunless North for 30,000 years? Something was quietly covering the bill. It was dinner. Vitamin D doesn't only come from sunlight. It comes from food, if you eat the right food. Fatty fish, liver, marine mammals, eggs, wild game. Exactly the menu of northern hunter-gatherers. A salmon and reindeer diet is basically vitamin D on legs, so their skin didn't need to change. Dinner was doing the sun's job. That's also why some Arctic peoples never went very pale, even at the top of the world. Their food carried them. You still use this side door, by the way. Every time you eat salmon or eggs, you're taking the hunter-gatherer route to vitamin D. Skin color, it turns out, was never just about latitude. It was a three-way deal between sun, skin, and diet. And for 30,000 years, that deal held. Then humans invented something that tore it up. Not a weapon, not a disease, a field of wheat. Around 10,000 years ago, farming spread into Europe, and farming flipped the menu. Out went the fish and liver. In came wheat, barley, porridge, every day, forever. Grain will feed a village, but it carries almost no vitamin D. The dietary loophole slammed shut. Now the North's weak sun was the only source left, and dark skin was still filtering most of it out. The pressure that had waited 30,000 years finally hit with full force. Picture the village. Everyone eats the same porridge. Everyone lives under the same weak sun. The only variable left is how much of that sun your skin lets through. Suddenly, every percent matters. And evolution had a candidate ready. A tiny copying error in a gene called SLC24A5. One changed letter out of 3 billion. That one letter dials melanin production down hard. In a sun-starved, grain-fed Europe, carrying it meant more vitamin D, straighter bones, safer births, more surviving kids. So it spread like a rumor. In a few thousand years, it swept across the whole continent. That's why truly pale skin only became widespread in roughly the last 8,000 years. Read that number again. 8,000. Farming is older. So if your skin is pale, that trait is younger than bred. And here's where the story pulls its best trick. Because none of that explains East Asia. Northern East Asia has the same weak sun, the same vitamin D problem, and people there also evolved lighter skin. Same outcome. So, same mutation? No. That European letter change is almost absent in East Asian populations. Their skin lightened through different genes entirely. Different mutations, different molecular route, same result. Biologists call that convergent evolution. It's what happens when a problem is so real that life solves it twice, independently, without copying. Two separate populations, thousands of kilometers apart, each invented lighter skin from scratch. That's the headline most versions of this story bury. Light skin isn't one invention, it's at least two. So next time you're in a crowd, run the experiment. Look at the range of shades around you. You're not seeing different kinds of people. You're seeing one problem, solved locally, over and over. And no single switch controls any of this. Skin tone runs on dozens of genes, which is why every population contains a whole range of shades. There was never a moment when one kind of human became another. There were just bodies, quietly retuning themselves to whatever sky they lived under. Which brings us back to the man with dark skin and blue eyes, because I owe you a correction. So, about that face. There's a famous reconstruction of Cheddar Man. Dark skin, blue eyes, staring out of a museum case like a photograph. That's the real photo, not a drawing. That's the model they built. It's worth knowing how that image was actually made, because you can't read a paint swatch off 10,000-year-old DNA. What geneticists really get is a probability. This mix of gene variants in this ancient genome usually goes with darker skin. That's why the team itself said probably, and meant it. So, was Britain's first known resident dark-skinned? Very likely, and clearly far darker than most people in Britain today. Do we know his exact shade? No, nobody does, and nobody honest claims to. So when that reconstruction stares at you, remember what it is. An educated guess, wearing very confident lighting. That's not a weakness in the story. That's what knowing something actually looks like. And the big pattern doesn't hang on one famous face anyway. Dark for 1,000,000 years, light only recently, invented twice. That's written in hundreds of ancient genomes. So, why did humans become different colors? Because the sun asked a different question at every latitude, and skin answered, run the ladder. Over 1,000,000 years ago, bare skin goes dark under African sun. 60,000 years ago, humans walk north into weak light. 10,000 years ago, Cheddar Man's Britain is still dark-skinned. 8,000 years ago, farming kills the loophole, and pale skin sweeps through, twice, on two continents, through two different sets of genes. Today, you can override the whole system with a supplement bottle and a plane ticket. But the dial is still in your skin. Every shade on Earth is the same machine at a different setting. So skin color can't rank people. It can only tell you where their ancestors walked. Two people, opposite ends of the planet, opposite shades, same species, same machinery, same sun. It just asks them different questions.